Welcome to this video. I'm Mr. Eicher and I'm going to be talking about some steps about how to do our assignment number 7 about magnets and pain, page 257, number 76. I'd recommend reading that problem, all the parts, before you start using R. So, as R says, we have magnets and pain, so we need the CSV from the wiki. That would be on this tab. And we have, let's see, magnets. There it is right there. Download that, save it onto your desktop or into your R folder, wherever you get your files. If you want to see where you're storing your files, you can type get wd, and I created a folder on my desktop, and the folder is called R. So that's where my files are. Next I'm going to go to directory. You won't have very many files in your directory. I have quite a few files. After you've saved the CSV file into your R folder or on your desktop or in my documents, wherever you save things, you're going to see I have 143 files in mine. Quite a few things in here. But I need the magnets. I'm going to copy this so everything's typed correctly. And I'm going to name it magnets. Use my operator >, read.csv quotes, and paste that in there. And when I hit enter, it looks good. If I want to do a summary of magnet, I see that there's an active, an inactive, and then an all subjects category. If you actually want to see the data itself, that's always helpful. You can go magnet. And notice that with the active treatment, here are all the responses to the active magnet treatment. And there are 29 of those. And here are all the responses to the inactive magnet, which there were 21 of those. And in this column, all subjects, I've just combined all of those for a total of 50 responses. So, as the project says, Part A, create comparative box plots using R. Remember to describe what you see. So to do that, we're going to do box plots, no capitalization, and we'll just say magnet, and that gives us a real quick box plot. I would recommend adding in the main title at the top. You might want to make these horizontal. Remember, you can make them horizontal by going to the next line, hit the up arrow, and it'll retype it for you. Do comma horizontal equals true. And now you have a bunch of horizontal box plots. There is a way just to do active and inactive, but for the purpose of this assignment, we'll just leave it like this. You can compare the active and the inactive. So for part A, it says compare the box plots. Remember, when you're comparing box plots, you should compare, use comparative language, and talk about shape center, spread, and outliers. You won't really be comparing the all subjects. You're just comparing active and inactive. But again, make sure that you have an X label, something there, and a main title, something there. You'll have a Y label if you don't make it horizontal, but it'll look something like that where you're plugging in information for the dots. Part B, do this in R and show your code and output. I forget what it was asking. Maybe it was asking to find the mean, perhaps. So if we want the mean of magnet of the active treatment, oops, the mean is NA. That's rather inconvenient, so we can use NA remove equals true. I don't know if I mentioned that in the manual, but that's na.rm equals true. Use that when you have NAs. As you can see up here, you have a bunch of NAs because of how the file was. Another way you can get around that is, I think this will work. You want the mean of magnet active. Let's see if this works. And you just want the first 29 elements. So see if that works. Nope. Well, I guess this way is the best way to do it. You could also find the mean of magnets inactive, and you need na.remove equals true. And those are the means. You could also do the standard deviation the same way. Just get rid of mean, and you have the standard deviation. And you could find the other standard deviation of the active treatment. Part C, you don't need to use R here. That's good. Part D, you're going to make a simulation. And that can be pretty complicated, so that's one of the reasons why I made this video. So let's start with, you want all subjects, and that is magnets, is where all subjects is found. So you're going to use all subjects. What you're going to do is take a sample of all subjects. Oops, sorry. Magnet. All subjects. So if you compare this original with this one, basically it's scrambled all these elements. So what you need to do now is you need to sample all magnets. I guess I could just hit the up arrow. And you just want the first 29. We're going to be randomly assigning individuals in a new way to compare to see if the treatments had any effect. So notice now we just have 29. We don't have all 50. That was 50 up here. Now we just have 29 of them. And we'd like the mean of all that. So if we go here, type mean, and that parenthesis. So that was the mean of that sample. If we do the same thing, but now we want not the first 29, but the last 20, that would be the 30th to the 50th, right about there, and find that mean, we have that number. What we'd like to do to see if there's a difference between the two means, we'll do active minus inactive. So this was active, got 29 subjects. We're going to subtract this one, which was the inactive, and hit enter. So the difference between the two is that. And if you read the problem, the actual difference from the experiment is listed, and that's going to be important, so you can answer question D. To do this simulation, though, we want to do this whole process a large number of times. So we could do this and just keep redoing each one, but that would take a long time, and then we'd have to graph all of these values, which we don't want to have to do that. So we use the replicate option, and we can do 10,000 trials. How about? Do a comma, and after that you're going to type in all the stuff that we kept repeating over and over and over again. So we'll copy that, plug that in right here. Actually, I'm going to do 1,000 instead of 10,000 because it's going to be quite a bit. So when I hit enter, I'm going to see 1,000 simulated trials of randomly assigning people to the first group, 29, the active group, and then assigning the rest to the inactive group. So when I hit enter, I'm going to see a lot of numbers. So those are all the differences. That's a lot to take in. You know, over here I'm only at 600 so far. I'm at, there's quite a few there. So it's nice, instead of hitting enter there, to name it like simul for simulation, and then use your little operator, less than, equal, and then a dash. And now when you hit enter, you don't see all the numbers. So now we can do a histogram of simul. And there's our histogram. This histogram should look kind of like the dot plot in the textbook. But you're going to use this histogram to compare what the actual result was with what it would be if the treatments had no effect. So as usual, you want to include a main title. You should have an X label, X lab. The Y label is frequency. You can leave it like that. If you wanted to change it to something, you could always use Y lab equals quotes. For sub, I think it's helpful to say this is assuming the treatments had no effect. The only difference, or the only reason why we saw the effect we did, is because of random chance alone, not because the treatments did anything. You can change the color of the histogram if you want. We'll change it to sky. sky blue. How's that? So you see all my dots up here. That's my main title. Over here, that's my Y title. My X title's down there. Assuming the treatments had no effect. So I hope that this was helpful. You can always pause and go back. If you have questions, you can see me in class. Have a nice day.